It's a beautiful sum which you are going to do. It is going to be very interesting and very, very important, student. Now let's understand what it says, that let X be a point on side AC of triangle ABC that is given. It says that XM and XN, we have two segments, XM and XN, they are drawn parallel. XM is parallel to BA and XN we have parallel to AC, meeting at points N and M respectively. It's given, right? It says further, to prove is very interesting. It says we need to prove Tx square is equal to TB into TC. Now, when you look at the to prove and see in the figure, you'll say it's so confusing. How do I get this? Don't worry. Always remember, focus on the to prove. That's what I always said. Focus on the to prove. Now, when I say Tx square, it is nothing but Tx into Tx. That means we want a product equal to a product, right? When I say I want a product equal to a product, we know that you will get it provided you get two ratios to be equal. If you put that in the form of ratios, it's going to be very easy. What we have is nothing but Tx into Tx is equal to Tb into Tc, right? Now, one Tx we can move in the denominator, one Tx remains in the numerator, right? So, one Tx goes in the denominator there. Now, anything from there can come here. So, that means you're going to get two ratios, where one Tx is in the numerator, the other Tx is in the denominator. That means we can form the ratios like this. Tb upon Tx is equal to Tx upon Tc. That means we are saying that we will get this product equal provided we get these two ratios equal. And we know we get two ratios equal provided we get two triangles to be similar. It says there are so many triangles. How do I identify which one? I have taught you a method. Numerator will give you a triangle. Observe TB and TX. Observe TB and TX. TB and TX. Is it giving a triangle? No. You will say in all most of the sums it was giving. Not here. Because here it is not giving, because all these 3 points which you look, TB, TX, the 3 points TB and X are collinear. So it is not going to give you a triangle. So then how do we do it? If you look at the denominator also, it is not going to give you a triangle. TX and TC, TX and TC, they are also collinear. Then how do we get this? This shows that we can't get these two ratios equal only by proving one pair of triangles similar. So then how do we do it? It's very simple. So what we'll do is, for getting the first ratio, we'll consider one pair of triangles similar. Then for getting the next ratio, we'll consider the other pair of triangles similar. Are you getting? That's important here. So understand. Don't get upset. It's going to be very easy, right? That's the way you start thinking. So now for TB upon TX, how do we identify which one? So we'll take a triangle which has TB. For TB, yes, we'll consider this triangle TBN. And I'll tell you why we are going to do that, okay? And for TX, I'll consider triangle TXM. You know why I took these two triangles? Because see, you can't, it's not that for those sides you will consider any triangle. We have to take triangles such that we can prove it similar. That's important. In both these triangles, one thing is very clear, there's a common angle T. And you know what? One more information in the sum, given in the sum, which is going to hint this. We have this AXM and this line to be parallel. Observe, look at the given now very carefully. What I'm highlighting? XM and BA, they are parallel, right? And that is going to help us to prove these two triangles similar. Are you getting it? Because when these two lines are parallel, we have a transversal which will give us a pair of corresponding angles. So we are going to consider that. That's the reason we consider those two triangles. Understand? So we have that AB and XM parallel, but AB, we'll write it as BN, right? So BN is parallel to MX. We know the reason, it is nothing but A dash N dash B. Now we consider the transversal, that is nothing but TX is the transversal. So get a pair of corresponding angle here. That is nothing but we have an angle here, that is angle TBA congruent to angle TXM, and that is what we write here. These two angles are congruent. And the reason here is nothing but we have the reason there as corresponding angles theorem, and that's our result number 1. Was that easy? Very important. Now this we have got. Now this will help us to prove the two triangles similar. So let's consider the two triangles. So now we write here in triangle TBN and triangle TXM, we write that. In this two triangle, we have this pair of angle which is already congruent, and that we got it from where? We got it from 1. First we write that, and we know the other one. What is the other one? It's a common angle. We write that common angle, that is BTN congruent to angle XTM, and we got this. The reason is nothing but common angle. Hence we get both the triangles to be similar, and we get the triangle similar by a test of similarity. So my dear child, we got the triangle similar. Why did we do that? We wanted this ratio. And we know that when two triangles are similar, we get three ratios to be equal. Let's write all the three ratios. So let's go one by one. So we get TB upon TX. Beautiful. That is equal to the next ratio, BN upon XM. The next ratio, that is TN upon TM. This ratio, they are equal. Why are they equal? The reason is CSST, corresponding sides of similar triangle. And that's our result number 2. Easy. So we got this, and there we have got the ratio which we wanted, TB upon TX. That's there. Beautiful. So one pair of triangle, when we proved similar, we got the first. Now the next pair of triangle which we'll consider, which will give us the next one. Now you should know how to get that, right? Observe now very carefully. If you look here, for TX upon TC, for TX we'll consider triangle TXN, and for TC we'll consider triangle TCM. Why did we do that? Because if you look at the information which is given to us, parallel lines which are given to us, we have this XN and AC parallel. That's the reason we took that. For these two parallel lines, we have a transversal, and because of that, we get a pair of corresponding angles equal. That is nothing but angle TXN equal to angle TCM. We got that. And this is nothing but it's a pair of corresponding angles. The reason is corresponding angle theorem, and that's our result number 3. Now, can we consider both the triangles? Yes, we consider both the triangles. We write in triangle TXN and triangle TCM. In both the triangles, what do we get? One pair of angle which is congruent already from 3. Reason is from 3. We write that. Next one is a common angle. That is angle XTN is congruent to angle CTM. And the reason is common angle. Therefore, we get both the triangles to be similar. And the triangles are similar. Reason is by AA test of similarity. Why did we prove the triangle similar? To get the ratios equal. Let's write all the 3 ratios equal. So we get TX upon TC, right, is equal to XN upon CM is equal to TN upon TM. These ratios are equal. And let's say that's our result number 4. And the reason is CSST. So now what has happened is, first ratio TB upon TX, we got that. That is in result number 2. And TX upon TC, that is in result number 4. But we want this 2 to be equal. When will this become equal? If something from both the statements become equal. And that is already there. We look at TN upon TM, TN upon TM. That means these 2 are equal. That means all the other remaining ratios are equal. We want only 2. Which ratio? We want TB upon TX and TX upon TC equal. Can we write that? Now in the next step, we'll write that TB upon TX is actually equal to TX upon TC. And from where did we get that? We got it from 2 and 4. And now just cross multiply. So what do we get? TX into TX gives us TX square is equal to TB into TC. And we got the 2 proof. Wasn't that easy? It's a very important sum, a beautiful sum.